What I'll do is, just to help you guys understand it better, I'll draw the recursion tree diagram. So when I look at this function, this is a height function. I'll first call it for the overall root, which is 5. So this has been called. Now, all that you have to do is you have to look at it and you have to figure out how the code control flows. So this thing, it is not null. So this condition will be skipped. You will come here. Coming here means you will invoke the call on the left child of 5. So you will call height function for 2. And here you will call height function for 1. Okay. Now we know how recursion works. You come from here to here. So now you are at this particular node. This particular node again is not null. So you will make a call to the left and right child of 2. The left child is 1. So you will call height of 1. And the right child is 3. So you will call height of 3. So now you will come from here to here. Now again, you are at this node, which is not null. So you will make a call to the left and right child of 1. What is the left child of 1? The left child of 1 is null. What is the right child? That is also null. So you will call height for null and height for null. So control came from here to here, here to here, here to here. What will happen at this point of time? Just look at the code and tell me. It will return 0. Just look at the code. It very clearly says that if the root is null, return 0. What is the meaning of this line? The meaning of this line is that if you want to compute height of a tree whose root is null, then its height is 0. That's all that it's saying. And here, in reality, you are trying to find the height of this tree, which is 0. That is the reason you should be returning 0 from here. Okay. Now, this call would be made. Again, from here, you will return 0. Now, when height of 1 was called, you made a call to your left child, got 0, made a call to your right child, got 0. And now what will you return? This function will return 1 plus max of 0, 0. 1 plus max of 0, 0 is 1. So it will end up returning 1. And it is correct to return 1 because height of 1 means height of just this much tree. And height of just this much tree is 1 unit. Do you see how values are being returned from the bottommost nodes and how they are being consolidated and how they are being sent upwards? Is it making sense to everyone? Yes or no? Yeah. You know, same thing you can keep doing on and on. So height of 2 will now invoke height of 3. So what is this 3? This 3 is not null. So you will call left child and right child of 3. The left child of 3 is 7. So you will call height for 7. And then you will call height for null. Now you are at 7. So again at 7, you will call height for the left child of 7 and height for the right child of 7. So the left child of 7 is null. The right child of 7 is also null. And from null, we return 0. And now what will happen here? Here, you will return 1 plus max of 0, 0. Your left height and right height. So you will return 1. And it makes sense to return 1 because when you look at the tree rooted at 7, its height is 1 unit. Correct? Similarly, this is again null. You will return 0 from here. And from here, you will return. Can you tell me what will height of 3 return to its parent? It will return 2. So it will return 1 plus max of left height, right height. Left height is 1, right height is 0. Max of 1, 0 is 1. If you add 1 to it, that is 2. And it is again correct to return 2 because the height of this much part is 2 units. Now again, what will you return from here? 1 plus max of 1, 2, which is 3. So you return 3 from here, which again is correct because when you look at the tree rooted at 2, its height is 3 units. Similarly, can you draw this part like height of 1 calls height of 9, and then can you draw that part on your own? Yes or no? So what will this return? Any ideas on what will height of 1 return? It will return the height of this part, which is 2. And now what will this return? It will return 1 plus max of 3, 2, which is 4. That's how you will get an answer of 4. Is it now making sense to everyone how the code works? So again, just to let you know, termination condition is the first part of your code, which you will be writing in your all the problems of trees. And then you call it as calls to LST and RST, or you call it as recurrence relation, which shows that how height of root is dependent upon height of root left and height of root right. If you learn how to craft such kind of equations with appropriate termination conditions, almost all the job is done.